Ho, 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 ho. 5 of the advent of code. Today, we're helping a gardener plant marijuana. Well, not really. We're not in Amsterdam, we are on Island Island, but it will be fun anyways. Let's give it a go. Part 1. So we have a series of seeds at the top of the input file. In this case, we had 4 seeds. And then we have a series of sections where we are mapping the previous element's position into the next element's position. So we go from seed to soil, from soil to fertilizer, from fertilizer to water. What we need to do is that we feed into this chain the seeds that are going to be translated into the soil, that are going to be translated into fertilizer, and at the end, we're transforming into a location, and what we need as a result is the minimum location we get out of all of this. Now, let's explain how these sections work. So these are pretty much conversions where the first column is the destination, the second column is the source, and the third column is the length of the conversion range. So let's see it with an example. So this line here says that soil 50 is coming from seed 98. But since the range is 2, we also have soil 51 coming from seed 99. And the same goes for the line here, which says that soil 52 is coming from seed 50, soil 53 is coming from seed 51, so on and so forth for 48 times. Okay. Yeah, so let's see how this is solved. So we split all of the file by double new line because that's how it's formatted. And we first parse the seeds. Nothing complicated here. We just extract those 4 seeds into integers. And then what we do here is that we go section by section, starting from section 1, which is where we have the first translation. And what we do is that we take each conversion line and we add the conversion to all of the elements that we need to convert. Now, if you remember, we had this input here, right? And let's take as an example like 97, 99. So when we convert, we actually get back the converted seeds and some more seeds to do. We need to do this because, for example, in this case here, when we process 97, this 97 would match this line here, because this line here says take seed 50 and transform it into 52 for 48 times, which means that we also take 97 and we transform it into 99. And when we do the transformation, we don't want to do it again also for this conversion rule, because also this conversion rule would now match, because this says take seed 99 and make it and translate it into soil 51, right? So that's why we actually need to separate what was converted in this section versus what's left to do in this section. And then we pretty much go through all of the sections thanks to this for loop. And at the bottom here, we calculate the minimum location for the answer. And the conversion function is pretty simple. We take all of the elements that are a slice of int and the one rule that we're trying to apply in this case. If our element falls into the range of the rule, we add it to the converted list. If it doesn't, we add it to the to-dos list. Okay, part 2. As always, there is a twist that changes everything. In this case, the only thing that changes goes as follows. So we don't have any more 4 seeds. We actually have ranges of seeds. So the first range is all of the seeds that start at 79 for a length of 14. So we have seed 79, seed 80, seed 81 for 14 times. And then here we have 55, 56, 57, so on and so forth for 13 times. So this time we actually have 27 seeds. Okay, how do we do it? So we have a range struct which has start and end coordinates. And then we parse the seeds. This time we don't parse a slice of integers, we parse a slice of ranges, but the rest remains the same. And the conversion function and the location logic are pretty much the same, with just a couple of differences. One is that here we're converting ranges, and before we were just converting from int to int. And when we look at the location, we just take a look at the start of each range, which is always going to be the minimum for the entire range. Okay, so let's take a look at convert ranges. Now, this is a bit longer, but it's not so more complex. The way it works is that we check each of the possible cases when it comes to two ranges overlapping or not. So the first if is the case where the element is overlapping completely into the rule. In this case, we mark it as converted and we actually shift it all. The second case is where the element is absolutely not overlapping on the right of the rule, so we keep it in to-dos. The third if is where the element is on the left, not overlapping, so we leave it in to-dos. The fourth case is where we have some overlapping towards the end of the element, which is this part here. So we actually end up with one part that is left to do and one part that is converted, which is this part here. And the same goes for the last case, which is the symmetrical case to the previous one. And that's day 5 of the advent of code. As you can see, we cannot really brute force stuff anymore. I actually tried a different solution than the one I presented today, and it was taking something like 5 minutes. So yeah, we need to start being smart, I guess. Let me know what you would have done differently in the comments, and I'll see you in the next one.